Hello and hi. So I'm Muhammad Irfan bin Main, who is the first presenter for this presentation. So in this first slide, I will share about introduction for electrical machine safety. Electrical machines are the backbone of modern industry and infrastructure. However, their operation carries significant risk if not properly managed. In this presentation, we as a group will cover 4 key areas, which is the first one is key international and safety standard that govern ethical machine. The second one is the legal compliance requirement in our region. Third is a practical application scenario showing how an engineer ensure compliance. And the last one is critical reflection, which is why adherence to this standard is not just a legal requirement but an ethical imperative. So let's dive into the first part, key safety standard. Alright, we begin with the IEEE, the Institute of Electrical and Electronic Engineers. IEEE sets globally recognized standard for electrical and electronic system. For electrical machine, key standard include IEEE 112, which defines test procedures for polyphase induction motors and generators. The second one is IEEE 115, a guide for testing synchronous machine, and IEEE 43, which recommend practice for insulation resistant testing. So why are these important? So IEEE standard ensure consistency, safety, and reliability in testing and operation. They help engineers worldwide speak the same technical language and uphold safety across borders. So next, we move to the next slides. Here we have the International Electrotechnical Commission or IEC standard. The IEC 60034 series specifically address rotating electrical machine. Important part include IEC 600341 covering rating and performance. The second is IEC 600345, which define degrees of protection known as IP codes. And the last one is IEC 6003430, which classifies motor efficiency through IE codes. So this all relevant to electrical machine, which is IEC standard harmonize international requirement, promote energy efficiency, and ensure machines are safe for different environment, whether in a dry control room or a humid industrial plant. So that's all from me. So we go to the next presenter. Thank you.
So we have covered the technical side, but what about the rules we have to follow? That brings us to OSHA. Under OSHA's subpart S, there are a few specific codes you will see constantly in that field. The big one is 9010.147. This is the virtual procedure that ensures a machine is fully off and stays off while someone is working on it. We also have specific standard for power generation, that is 9010.269, and general requirements in section 302 to 308. Ultimately, OSHA goals here is simple. It mandates the employers can just send you in blind. They are required by law to train you and have compliance programs in place to protect you from electrical hazards. Next, we have the NEC standards, technically known as NFPA 17. While OSHA focuses on worker safety, the NEC focuses on the safety of the installation itself. For electrical machines, there are 3 articles you need to know. Article 430 covers motor and controllers, while Article 445 deals with generators. Usually, we also have Article 250, which sets the standard for grounding and bonding. Ultimately, the NEC provides the requirements For safe operations, it's specific exactly how to protect equipment against overload and short circuits, and outlines the proper grounding method needed to prevent electrical shocks. Moving from the national standard to the local landscape, let's look at the Malaysian context. We are primarily regulated by three key authorities: DOSH, the Department of Environment and the Energy Commission, locally known as Suruhanjaya Tenaga. To stay compliant, we must adhere to specific laws, most notably the Factory and Machinery Act of 1967 and the Occupational Safety and Health Act of 1994. Finally, validation is key. We cannot operate without SIRIM certification for our equipment, energy efficiency levels for motors, and perhaps more importantly, ensuring all electrical work is performed by a licensed competent officer.
First, let's look at the specific safety requirement for DC and AC electrical machine. Lockout and take-out procedure must always be followed during maintenance to prevent accident and causation. This includes shutting down the machine, isolating its power source, applying lockout and take-out devices, and verifying that all energy has been fully isolated before work begins. After maintenance, the system must be safely returned to service. Next is grounding. Proper grounding is essential to protect workers from electric shock. All equipment must be used correct grounding conductor, proper system grounding method, and ground resistant to testing to ensure effectiveness. Lastly, installation standard must be maintained. Installation resistance testing should be carried out regularly according to IEE 43 standard. Minimum resistance value must be met, and environmental factors such as humidity and temperature must be considered. Now, let's move on to the application scenario. This scenario involves a manufacturing plant in Malacca installation a new 150 kilowatt induction motor for a conveyor system. In this project, engineer must ensure all safety standards and legal requirements are followed. This includes selecting a motor that meets IEC efficiency standards, applying proper grounding and protection based on an EC requirement, and performing installation and performance testing according to IEE standards. During installation, only qualified personnel are allowed to carry out the work, and lockout and take-out procedure must be strictly applied. This helps reduce risk and ensure safe operation. Finally, we have the engineer compliance checklist. Before installation, engineer must review all relevant standards, prepare compliant electrical design, and obtain all necessary permit and approval. During installation, safety procedures such as lockout and take-out must be followed. Proper grounding must be implemented, and only certificate components shall be used. After installation, comprehensive testing must be carried out. All compliance action should be documented. Operator must be trained on safety procedure, and regularly maintenance schedule shall be planned. By following this step, engineer can ensure electrical machine installation are safe, legal, and reliable.
Safety imperative. Now, why ethics and safety are non-negotiable in engineering and technical work? First, worker safety is a critical priority. Proper safety standards help prevent serious hazards such as electrocution, arc-flash injuries, burns, and equipment-related accidents. By following established procedures and using protective equipment, we significantly reduce the risk of injury or loss of life at the workplace. Next is public protection. Engineering systems often operate in a shared or public environment such as buildings, roads, or utilities. Ethical design and safe operation ensure that the system do not pose the risk to the general public. A single failure can affect many people, so safety must always come first. We also have environmental stewardship. Ethical engineering promotes engineering efficiency, minimizes waste, and ensures proper disposal of hazardous material. This helps reduce environmental damage and support long-term sustainability. Another important aspect is legal obligation. Engineers are required to comply with laws, standards, and regulation, making this requirement fulfill our duty of care and protects both the public and the professional involved from legal consequences. From a professional responsibility standpoint, engineers have an ethical duty to prioritize public welfare above cost, speed, or convenience. Adhering to ethical codes demonstrates integrity, accountability, and professionalism. Ultimately, this commitment contributes to sustainable engineering practices and build trust in the profession. In summary, ethics and safety are non-optional. They are fundamental to responsible engineering and to protecting people, the environment, and society as a whole. Emergency response in the project area. This slide, we focus on why having an effective emergency response plan in the project area is essential. First, let's look at safety risks. In project sites, especially those involving electrical system, emergencies can include electrical fires, explosion, electrocution, arc flashes, incidents, and that can cause severe burns. Without clear response procedures, the situation can escalate quickly, leading to serious injuries or even fatalities. A fast and well-coordinated response can significantly reduce harm and save lives. Next is reputational damage. When emergencies are poorly managed, public trust can be lost. Incidents may attract negative media coverage, which damages the organization's image and credibility. Over time, this will make it difficult to secure future projects or contracts, as clients tend to avoid companies with weak safety records. And finally, we have the legal and financial risk. Organizations may face regulatory fines and penalty for non-compliance with safety laws. Civil lawsuits and compensation claims can arise from injuries or damages. In addition, incident often causes business interruption, leading to loss of productivity and revenue. In severe cases, insurance coverage may be invalidated if proper safety measures were not followed. In summary, a strong emergency response plan is not just about reacting to accidents. It protects lives, preserves reputation, and prevents serious legal and financial consequences. To conclude this presentation, safety and ethical standards are the foundation of all engineering work. First, standards provide a clear framework. Organizations such as IEEE, IEC, OSHA, and NEC establish minimum safety requirements that guide engineers in designing, installing, and maintaining safe systems. These standards help ensure consistency and reliability across projects. Second is legal compliance is mandatory. Engineering work must follow regional laws and regulations, and failure to comply can result in serious legal and professional consequences. Compliance is not optional, it's a core of responsibility. Third is application requires diligence. Simply knowing the standard is not enough. Engineers must apply them systematically and carefully throughout planning, design, and execution to ensure compliance and effective risk control. Most importantly, adherence is non-negotiable. Safety and ethics demand strict and consistent application of standards, regardless of time, pressure, or cost constraint. As future electrical engineers, our commitment to safety standards protect lives, preserve the environment, and upholds our professional integrity. By doing so, we build trust, ensure sustainability, and contribute positively to society. That is all. Thank you.